Okay guys, welcome back. Here's another example here on trigonometry, the one that we know that always is called trigonometry because it's a bit tricky for us. So but I mean, if you got maths with Gaston behind you, I don't see why you should be struggling with this chapter. Please consider giving us a subscribe and like this video and share it with your classmates, your friends, and everybody that needs it. I am Gaston Mapala. Let's go through this one. 5.1, it says here the diagram. A diagram is given you in terms of P. These are the coordinates here. It's X and Y. We always know that X is on the left hand side, and then is a point on the second quadrant. Very, very important. This part, very, very important. We know that on the second quadrant, X is negative. Please guys, they are not just saying this for the sake of saying it. Take note, on the second quadrant, this X value here, which here is symbolized in terms of K, is going to be negative. And then they are saying that and square root of 5 units from the origin, which is this one here, is a point on the x-axis and an obtuse angle of theta. Great stuff. So now simply what this means, it means that here this is our hypotenuse. So if you were to draw this in terms of the diagram, that's what you would have. Now first thing first, 5.1.1, they are saying that we need to calculate the value of K. Okay, we would know that in the value of K, we're going to apply Pythagoras theorem. In this case, this is what we're going to use. What do we have? We're looking for X. In this case, we don't have X. What do we have? We have got Y, which is opposite, and therefore it's 1. And therefore, we have got hypotenuse, which is square root of 5, all in close bracket like that. So therefore, this will be square root of 5 squared is going to give us 5. 1, if you take 1 to the other side, is going to be negative 1. Then you take the square root. The answer here will be plus or X is goes to plus or minus 2. Okay, so now we all know that is going to be minus 2. Why? Because of it's in the second quadrant, the X coordinate will therefore be negative. So you can come here and say therefore K will be equals to negative 2, right? So you can put here K, it's negative 2 as expected. Great stuff. So let's go to 5.1.2. Without the use of the calculator, calculate the following. They are saying tan theta. They want us to calculate tan theta. In this case, we know tan theta, guys, is going to be, for those of you who always forget, please watch other examples or use SOHCAHTOA. I can remember them. Let's see here. We're going to say it's what is going to be opposite over adjacent, which in this case is going to be 1 all over negative 2, which gives us a negative half. Okay, and then we're coming here. Question B is saying 180 plus. So 180 plus, in terms of simplification, guys, please don't forget this diagram. I give you this diagram is the god. It's everything. It's the goat when it comes to trigonometry. 180 minus on this quadrant, 180 plus on this quadrant, and therefore negative on this quadrant, 360 minus on this quadrant. So please guys, therefore you've got cast here, you know what is positive here and what is not. So 180 plus in the third quadrant, it means cos is negative, is going to be cos theta, which in this case is going to give us adjacent over hypotenuse, which is negative 2 over square root of 5. Looking good so far. Happy. Is in this case, guys, is going to be negative. So please note that is going to be negative, but also you also got the negative of the cos here, which is this negative outside, because there's this negative and also 2 is also negative. So negative times negative, which ultimately gives us 2 all over square root of 5, which is positive now because of negative times negative. Great stuff. I hope you guys are following. If you're not following, please let me know what is confusing you, or maybe I'm moving too fast for your liking. Let me know. Leave a comment. Any negative or positive, it doesn't matter, guys. I accept comments and then I will adjust. We're all of us are learning here. So if I'm not doing it right or I make a mistake, please let me know on the comment section below. So now let's move on to question C. It says here sine theta plus 60. We must express it in the form of that. 5 marks. Ow, this one they're just giving it to us now. Okay, let's see. Sine theta plus plus 60. This one here, guys, it's a compound angle. We know compound angle when it comes to sine. This is what we're gonna have. We're gonna have sine theta here times cos. Here is supposed to be cos, because this is sine. Cos, guys, this one you can look at your formula sheet. If I'm confusing you, look at your formula sheet, guys. You can't go wrong. Just look it up on the formula sheet. All right, so we know in this case that sine in terms of theta is going to be opposite over hypotenuse, which is 1 over square root of 5 as expected. Now cos 60 is what? We know cos 60 is half. This is a special angle, guys. I hope you still remember special angles: 30, 45, 60, and yeah, these are the special angles. So let's not forget the special angles. They give us certain values while we're busy with them. All right, sine 60 will therefore give us, sine 60 will give us a square root of 3 over 2. Then cos theta, we did find cos theta here somewhere, is going to be negative 2 all over square root of 5. Great. Now with that we can simplify further. I'm just gonna go ahead and punch this on my calculator. It is giving me 1 over 2 square root of 3 all over 2 square root of 5 all over 2 square root of 5. Okay, and then this 2 square root of 5 can also be rewritten as 1 minus 2 square root of 3 all over this square root of 5. Before it became like this, it was a square root of 4 times 5, which is equals to 1 over 2 square root of 3 all over 4 times 5 is equals to square root of 20. So if you were to take in your calculator and then say square root of 20 is going to give you 2 square root of 5, which makes sense. Great. So moving right along, let's move to 5.1.3. 5.1.3. It says here 5.1.3 said use a calculator to calculate the following, which is tan 2 theta minus 40. So they want us to calculate this value here. Okay, great stuff. So now let's see, but we don't have theta. But is it possible to get theta? Yes, we can get theta here because theta is unknown. So now if you look at the question A, we found out that, where's question A here? There it is there. We found out that tan is equal to negative 1 over 2 theta. So we can go ahead into our calculation. Here we go and do second function. We do it without putting the negative. Okay, we do it without putting the negative. Is going to give us a value of 26.57. However, we must check where is tan negative. Tan is negative on the second quadrant because this one here give us a reference angle. Remember a situation where you are calculating for the or solving for the general formula, guys. So it means here you're going to have, okay, therefore the actual angle will have to be 180 minus this part here, which therefore will give us an angle of 153.43. 153.43. Now this is the actual angle. So therefore on our equation on 5.3.1, which is this one here, we can go ahead and substitute this angle here and then find the equation. So we're gonna say tan is going to be equals to, in brackets, times theta, because now theta we know is 153.43 minus 40, close bracket. So therefore now this gives us a value of, if we to put this directly into our calculator, is going to give us a value of, I'm getting 18.3. just a value, guys, 18.3. Please let me know if you got the same answer or you got a different answer, or there's many ways to kill a cat. You would have done it differently. Please share with us on the comment section below. Let's move on to the next question, which is an identity question. I know you guys also sometimes we do struggle with identity question. Please know that you are not alone. We are here to assist you right here at Maths with Casting. So let's go ahead and look at this one. It says here, prove the following identity: cos plus sine all over cos minus sine minus cos minus sine all over cos plus sine. This one should be equal to 2 tan 2x. Great stuff. So now we're going to start here and tell the examiner that we are starting on the left hand side. So on the left hand side, if you ever look at this one, every time guys, if you see a fraction, always just go ahead and look for the LCD. Provided you are not solving, you are simplifying. Great stuff. So now we're just gonna come here and say, okay, now what is the LCD in this case? The LCD will be everything at the bottom, which will be cos x minus sine x, all in bracket cos x plus sine x. Okay, now what do we have here? We're going to say this cos x minus sine goes how many times here? It's like you are I always tell my analysts that this, in this case, it's like you're saying this one cancel this. What is left? You are left with cos x plus sine x, which will have to times the numerator here, which is cos x plus sine x. Okay, similar thing would apply here. You are saying cos plus x cancel cos plus x, you are left with cos minus x. Here you've got a negative, which is this negative here of the equation, so you're gonna have cos x minus sine x, all cos x minus sine x. Great, there you go. And then now the only thing that is left, guys, you just have to simplify and deal with the fraction. Great stuff. So we're going to start at the top, remove the bracket, binomial. This cos times cos is going to give us cos squared x. Then you're going to have cos times sine is going to give us cos and sine x. So you've got another one here, sine and cos x. So therefore you're going to have two of them. So plus 2. Guys, if you can't see what I'm doing, please do it separately here for the sake of understanding. To avoid making this video longer, I have skipped that part of getting the middle term. Okay, sine times sine is going to be plus sine squared x. Negative, don't forget this negative, very very important. Cos times cos, you're gonna have cos squared x. Therefore you're gonna have cos and sine, so you're gonna have negative 2 cos x and then sine x. Okay, and then a positive sine times sine with a negative sine squared x, all over. This one, guys, looks like a difference between two squares. If you know difference between two squares, I hope you didn't forget. But what you can do, you can also multiply throughout, first times first, last times last. So I'm just gonna go ahead because I've already seen what this is all about. So it's going to be just say cos squared minus the next one sine squared x. But guys, please, you can go ahead and multiply throughout. You're still gonna come here, right? So don't say no, this guy is busy doing videos on YouTube but he's skipping the steps. No, it's because even if you work it out and say this times that, this times that, and then sine times this, sine times that, first times first, last times last, you are going to have the same answer as me. So follow the steps. As long as you stick to the basics, at the end of the day we should have the same answer. Or pause this video, continue, let's see if we're gonna be able to see if the left hand side is equal to the right hand side. Okay, so here we've got cos squared. There's nothing that we can do for now. And then here also as well we have got cos and then sine. Here we go, sine, and then we have got plus sine squared x, negative, we're multiplying throughout by a negative here, guys, so all these signs will change. All right, so here you're gonna have cos squared x. Here you're gonna have negative times negative, positive 2 cos x sine x negative, in this case sine squared x. Therefore all over okay, let's just be patient and make sure that we don't make a mistake here. So far so good. Okay, I'm just gonna leave the square as it is here, cos squared x minus sine squared x. Okay guys, my wife just entered the building. All right, so as we continue here, cos squared will cancel with cos squared here, and then you have got a plus sine squared and a negative sine squared there. So when you add these two together, 2 cos, what are we going to have? We're going to have 4 cos x sine x, right? Therefore all over. Then at the bottom, what do we have at the bottom? What we can do at the bottom, we still got this cos squared. Now at the bottom, I want you guys to think carefully about this one, because now what are we looking for on the right hand side? We are looking for 2 tan 2x. So now at the top, you guys remember this identity here, which is 2 cos a, and therefore sine a. You remember this one. So now here we can change this identity here. We can write it in terms of 2, and then we can say 2 sine 2x. Okay, because when you change this one, it's gonna go back to this side. All right, very careful guys. Please pause this video, think about what I'm saying. If you expand this, it should go back to this one. All right, and then also at the bottom, we can also change this identity here at the bottom, can also be rewritten as cos 2x. Okay, go have a look at it at your formula sheet. So you can also write this one here, cos 2x. So therefore sine over cos can also be rewritten as tan 2x, which is equals to the right hand side. And with that, ladies and gentlemen, you are smiling and you're walking out of the exam with 5 marks from this question by simply following the basics. I am Gaston Mapala. Let me know what you think of this question. Very interesting question indeed. I will see you on the next upload, where we'll be doing more of mathematics. Could be any chapter, could be anything. Let me know on the comments, which chapter are you struggling with? What would you like to see? Which question do you have? Send it on my WhatsApp. I'm more than happy to do a video for you, and then you can watch it here on YouTube. See you on the next one.